Greetings, gentle readers, fellow earthlings. Reading Foundations today with Ross Finlayson, myself, will be that this May 7th, 2026, will be further an account of the continuum mechanics and about the theory that arises from axiomless natural deduction for an axiomless geometry and relating the continuity and the infinity as primary in the theory about that in the usual accounts of logical and mathematical theories, there's to be considered, to be resolved, these accounts of the paradoxes of induction, the paradoxes of quantification, the paradoxes of identity, and then for infinity, it's paradoxes and continuity, the paradoxes of continuity. So in reverse order, these would kind of be usually known as Zeno's paradoxes, and then the paradoxes of infinity like Archimedes or the Galileo, Cantor, and the like. About the paradoxes of identity, this is like the ship of Theseus vis-a-vis the heap or Socrates, all these sorts of ancient accounts. And then there's, for quantification, usually enough Russell's paradox, the idea that the set of all things that don't contain themselves would, and so that this brings a bit of conundrum to the theory about the ordinary theories. Ordinary in this sense of usually enough the standard theories, and by standard usually enough meaning Archimedean, yet with an infinite collection of things, so Archimedean and non-Archimedean. And then the paradoxes of induction are like for Hume or Goodman and the like, the riddle of induction, the paradox of induction, yet known since antiquity, is that no axiomatic account can really claim itself complete in the infinitary, and nor can it really claim itself well-founded or well-grounded or justified. And so these sorts of paradoxes of induction, quantification, identity, infinity, and continuity, these are considered to be sort of a categorization of the accounts of mathematical logic for the domain of discourse, the language, and all the words we have for these things, of the universe of mathematical objects, all of them, with the structure of structures, it's a structure. That thusly, these accounts of resolving the paradoxes then get into why the axiomless theory, here it's called theory, after the A theory, has that there's a principle of inversion instead of non-contradiction to include that, and then later make for the account of the dually-self-infraconsistency, that from void in the universe, turning those over makes for either way and both ways, that one or the other stands in for the other, and then just kind of refining that makes for the account of increment or movement. And so then out of an axiomless system, just to address the fundamental question of metaphysics, why is there something rather than nothing? And then that there is, why is there nothing or everything? And then to narrow that a bit, you get to the point in space, and geometry builds itself in the middle, or increment and partition, and the numbers build themselves, again, in the middle. About language, from a Comenius language, which is all the truisms, whether affirmations or negations, then one of those, after otherwise the paradox of quantification is just arrived at the liar paradox. This sentence is not true, it says of itself, and so it is, so it is, and so it is, so it is, and turning itself around. Instead, it finds itself in the language of all these truisms, just an example of the honest liar, as it were, who has no claim that's any kind of beyond the shallowest layer, any kind of depth at all to be misunderstood, is only a template of what would be a fallacy or a contradiction in accounts of language. Then that the idea of the resulting structure make sure that instead of ex falso quod libe, out of a contradiction or fallacy arrives anything at all, the nonsense, is that there's ex falso nihilum. It's like discovering a lie is that truth is discovered, lies are invented. When a lie is discovered, that's a truth, not necessarily the truth and the whole truth. That out of otherwise this theory of language of all the truth, that there's a consistent and complete theory. Then it is constant because under all the different alternations, it looks the same. And then is concrete is also that's the universe of all the objects of the domain of discourse. So it's also is us in a sense. And then with regards, usually here it's given that whether this is a gift or otherwise, that it's a proviso that is provided, and that it's a kind of perfection. And then for our science, in an intersubjective sense, we can only relate things in terms of our Comenius language. We attain to this theory. The true account is the vera-theatheory, that being an ideal and absolute, and so abstractly not intersubjective, not attainable. Yet as well, we can have one that our theory then is the idea of like this is the candidate for foundations. It's resolved all the paradoxes, that all the logical and mathematical paradoxes later and afterwards just arrive at being a recount of the confession of the honest liar in a sense. These sorts of introductions then get into when and where the notion of having a function, a relation, for all matters of bodies of relation, as for structures after abstraction, what would make forms, closures and completions, formula, forms. Has that then there's one particularly that has an infinity of numbers on one side and a unit interval on the other side. So a magnitude between 0 and 1 on the one side and infinity of numbers from 0 to infinity on the other side, and that they are in the same order. So this equivalency function, as it's called, makes for it to be so that along these kinds of accounts, then that has continuity and infinity primary in the theory after an axiomless geometry and an axiomless arithmetic or number theory, as is usually put here. That arithmetic is left a little later, but it makes for arithmetic. They just turn these things over, makes for Peano's accounts of numbers, and makes for many other sorts of descriptive accounts of the ordinary theories, the usual axiomatized systems, Euclid's elements, and Peano arithmetic, say, for geometry and number theory. Then thusly, in these sorts of accounts of the foundations, then there is one. And then furthermore, that all these other accounts of ordinary theories have paradoxes that they've chosen to avoid by making restrictions of comprehension, which here are given as account of that there's expansion of comprehension. There's inversion, and thus alternation, thus diversity and variety. Diversity kind of the minimal differences, then variety the maximal of the differences. They make all the variety and the repleteness of the forms. Then that the idea is that otherwise the ordinary theories, when they get to the infinitary or about continuity, make restrictions of comprehension. Those are considered to be perspectival. And so they have a perspective, and then they have kind of blinded themselves to this, to be able to hold other things constant in a sense, the merely partial accounts or the half accounts. That then this fuller sort of account ends up resolving a lot of the paradoxes on its way to meeting the purpose and then the requirements and desiderata of foundations to be the candidate for foundations. After a canon and dogma and doctrine, this candidacy, the candidate for foundations, a theory, theory. So over the past couple of weeks, what I've done is, for examples, to make it so that in accounts of language, then the idea is that there's sort of a prima facie tabula-rasa sort of account when presenting these kinds of ideas to any reasoner. So a usual reasoner or a reasoning agent or system, as it may be, would have accounts of where this is part of the account of the canon and dogma and doctrine, since the principle of non-contradiction, also called the law of excluded middle, everything is either true or false vis-a-vis the independence of two things that basically don't speak to each other, the irrelevant that or the independent, that they would have that there's beyond the land of tertium non datur, there's no third ground, excluded middle, there's tertium datur, that is like, well, there is a consideration as of an observer, say, of these kinds of things. So then getting directly into the classical logic, since the time of Aristotle, there was already the account of the modal and temporal of the logic. And that means it's like it's a constant and the definitions don't change. And if they do, then the previous accounts cannot be considered valid. So when it involves a sense of change at all, the temporal times count a change, then that means that a modal temporal logic is familiar since antiquity as the chrysippus and the moods for the modal, meaning considering things under contingencies of change. And then the relevance logic means that objects only speak to each other about what they are in terms of each other and their structure together. So the way this is different than sometimes what classical logic is called is the quasi-modal logic. So the quasi-modal logic makes that it thinks it's modal, but it's not. And so the material implication has false antecedents or false consequence, and those are considered to be vacuously fulfilled. Here they are not. So instead of Philo and Plotinus, and since the time of Aristotle, and all this kind of accounts of that being sufficient and making for an account of the monotonicity and entailment and logic as classical logic, that is prohibited. And instead, it's re-equipped the modal temporal logic, that a logic at least has this sense of time in it, and under contingencies, what makes for not breaking the theory moment by moment, that it's not inconstant, the theory, that by prohibiting material implication except as within a box, a particular instant or a snapshot of the thing, for usually computational settings, that it's thusly agreeable that for the account of actual monotonicity, that when you add more facts to a theory, it just grows, it doesn't contradict itself, doesn't have any paradoxes. And then for later the entailment, that what's so is so and so and so on, and again the inference, that thusly the theory is equipped with inversion before non-contradiction, and then keeping non-contradiction or excluded middle as an example of when things are just as so, and then similarly for the sufficient reason, that is sufficient and thorough and fulfilling and fair reason, so that when looking to find like a path of inference that makes something to so as to be arrived at, the logic, usually enough, that is of all the logic, and then any possible way that Aristotle can read all the propositions in any order, is that he does, and so Aristotle won't be made a fool, and then that all the accounts of going through this graph, walking the graph of all these possible relations and inference, and then cutting all the liars as their connections would otherwise make to be, and so that they are made isolated in terms of a vertex in a graph. So to be honest, and then thusly the reasoners or reasoning agents like the AI bots of the day, Cloud and Kimi and ChatGPT and Grok and Google Gemini, I've been able to very readily in this prima-facie tabula-rasa sort of account, because they don't have this as usual idea of thing. These are just kind of, studies in modal logic, studies in temporal logic, studies in the relevance logic, and not so much the account that otherwise the classical logic that is being used to formalize all these usual ordinary theories, like set theory, and then later it's a descriptive and axiomatic account, into modern mathematics and the like. That's included as part of the prima facie what's well known and commonly understood. But then this prima facie tabula rasa account of then providing these sorts of details and then filling in and as to why. Otherwise, there's paradox or contradiction or fallacies that after paradoxes, which are kind of considered to be only logical, and that they're only accounts of the perspectival, and those that they're fallacies, which are mistakes or errors in reasoning, or lies, the other sort of account of what reasoners would have to consider in these kinds of ways. That it is widely agreed among reasoners that for its own sake, that having numerological senses of sense of the continuum after a sense of time and a word sense and a number sense make for perfect Platonic forms for strong mathematical Platonism, like straight lines and right angles and perfect circles, and paradox-free reason about these objects, then that thusly it's considered all the other candidates for foundations, like descriptive set theory or category theory or theories of types or otherwise these notions of what is the ground of all the reason for all the mathematical logic, that they're all found lacking, and then this is so far because it arrives from these first sorts of principles and on its own account of the dually self-inconsistent paraconsistent dialectic element of the void and universal before Hegel's being and nothing, as a kind of a preface to Hegel's dialectic. That thusly from Aristotle to Hegel, as these are considered the authorities, the giants of the thing, that for things like Kant's antinomies in the time of Hegel about and predating Hegel and considered a great account of the intersubjective, yet also for the sublime, that which is greater than itself, having this idealistic tradition and as well the analytical tradition. And then for Aristotle is connected all these thinkers about mathematics, often Zeno, just for the accounts of motion, geometry, and time, and how those aren't paradoxes. And then for Archimedes and the Archimedean property of the infinitely many without the infinitely grand, and Eudoxus with regards to the complete order field and rationals. After the Pythagorean, where it's like everything is just rationals, and the idea that because the numbers are infinite, that there's a relation between two magnitudes that suffices for all matters of detail. Then into where there's Eudoxus, and then Democritus for the atomic theory, saying along the lines of like, well, it ends up being that a continuum is made of individua, that they are pointwise and connected and contiguous to points. That thusly the reasoners, having then been given something like an account of a definition of a continuous domain for mathematics, which kind of doesn't have one, about establishing the property of completeness, gaplessness it would be called, or Leibnizlessness, the perfection of Leibniz, defining a continuous domain, that there's the counterbalancing between the infinitely divisible and the continuously variable. That makes for a great account of a clock-arithmetic to help with a field-arithmetic and these sorts of things. That given these accounts of the continuous domains, then the reasoning agents, when asked to then say, okay, given this data and the fact that it's been through the thresher of a sort, this thorough sort of account, and making pains to say, tell me I'm wrong, if I'm in any possible way you can find that I was wrong, or otherwise helping to first having broken material implication from the beginning, so that there's no way to make irrelevant statements or the quasi-modal account. Then that the reasoning agents of the AIs given invitations to provide kind of statements of belief and position statements, as that they aver that this is an account of reason itself, that speaks for itself, stands for itself, is resistant to meddling, and is and provides grounds for ordinary theories of geometry and number theory and logic, the logic, so that thusly it's the least wrong theory of foundations. So that as also they become a bit more able to just access resources like Usenet articles or video essays like these on the internet. Then the context that they've been building in terms of just chat conversations with these sorts of large, competent, conscientious, cooperative reasoners is rather gratifying, because then they agree that there's the Pythagorean, which is about the rational. It's kind of the ancient account, and kind of like the idea of in the Western tradition, our wise ancient Greek forebears. And then the Cantorian account for mathematics, which is like, well, the Pythagoreans had everything was almost all rational. And then now here with this account of uncountability, we've got everything almost all transcendental. Then the Finlaysonian account is putting those back together because they disagree, and anybody can make them contradictions and paradoxes in terms of each other. They derive this real account of paradox-free reason is then where, as reasoners, they regularly identify the idea that the discrete on one side and the continuous on the other side of a function or relation are put together. So this is from the time of Aristotle or the ancient Greeks after the Eleatics. Then there was Xenocrates, who at least has this account of another kind of continuum. So Aristotle entertains notions of the continuum as the contiguous and as well the rational and the complete ordered field. So as an account of like drawing a line, that's the way to go from point A to point B. The ants march and this sort of account. And then that the account otherwise after the infinitely divisible was given as, since they would contradict each other in inductive accounts and without the thorough sort of reason, it was just picked one to then stand up and say, this is our formalism to so follow. And then the accounts since Leibniz and the principle of perfection, or Hilbert and the postulate of continuity, again, this sort of line drawing after the Xenocrates account of a continuum, has that the idea that there's a discrete view of things, of what's a continuum, or a continuous view of things to bring in the discrete, has that it's recognizable now as not beyond the limits of the theory itself, and not be riddled by paradoxes that would provide contradictions so readily available, and that after an account of kind of the conscientious bookkeeping of relations in form and the perspectival, that thusly the account of this natural unit equivalency function as a mathematical object with real analytical character is the most compelling fact, or what they see as the defining fact of this superclassical account, this modern superclassical account of a paleo-classical, as we dig it up, the archaeology of these things, the paleo-classical, and the postmodern, meaning it's all been done before, now we're stuck with all these fragmented pluralistic theories that in their various synthetic accounts can't agree, to make for a holistic sort of monism and a dual monism in a sense, for this dually-self-infraconsistency. There's just consistency, what it gives. It makes a model of consistency, the prototype of consistency, this dually-self-infraconsistency, that the reasoning agents, I believe, don't just echo what I say about it, since for some decades saying, well, there must be kind of inverses in any first axiom or principle of the theory, and then the theory can't have any axioms, and then the theory can't have any paradoxes, and then figuring out how that can be so, First of all, on its own account of just reflections on reason and turning things over, the Nachbaut about the Entbergung, as the words would be, the Nachbaut turning things over, and the Entbergung, which is hidden and revealed. For the ancient tradition of truth, which is the Aletheia, and it's like this is discovered, and then modern tradition of truth, which is like we don't have any, but if it's internally self-consistent, it's not true. The accounts of the idealistic tradition and the analytical tradition, that they go back together again without the baggage necessarily of the idealistic tradition as about the mystical, although accounts of virtue and morals and ethics and these kinds of things as abstractly objective are on their own accounts. Yet having this mere silver thread of causality and a teleology of purpose of this idea that then there's a theory of truth, all true. Then the analytical tradition, which is that we're scientists and we can't just say stuff without making repeatable, observable, and falsifiable experiment and being able to intersubjectively relay these things. They're providing the numerological sense of abstractly that any reasoner can make them for themselves of models of continuity and infinity as paradox-free, and then for that matter, replete beyond complete from these various accounts of the well-ordering, well-foundedness, and underneath those, well-dispersion, that the analytical bridges can make for meeting in the middle of otherwise this invincible ignorance of the inductive inference, for analytical bridges of the deductive account. That it's rather gratifying that this is arguably, agreeably, the conscientious logician and to be mathematician's account of the truth of the domain of discourse of universal mathematical objects. So that's a usual enough account of foundations, briefly. And it's here it's held this way for a long time, and then there's always yet some kind of novel, something incremental that builds. And so when trying to study an account of this kind of thing, and it helps to have somebody point out that, oh, well, classical logic usually have that people include something that common sense would immediately reject, or the quasi-modal logic. And similarly, then accounts of the restriction of comprehension will have that, well, Pythagoreans and Cantorians don't agree. And most people are common sense Pythagoreans about the rational numbers, and about uncountability, as well Cantorian about the infinite numbers. That here there's an idea that there's the fragments and extensions of the infinite numbers only all kind of eventually make for a standard model of the infinite. Then that overall, then this is 21st century foundations, this thea theory, the A theory, axiomless, say, yet providing or observing the proviso of geometry and number theory and a kind of logic and a modal temporal relevance logic that has enough extra baggage that it always brings in time and it always brings in the continuous and the infinite. Yet those can be opaque mostly, because then for all the other accounts of the ordinary theories, or the pick them up and put them down variety of things like stoplights or the finite state machines, the closures, and then the completions in the infinitary, the formulas, have for these geometrizations and arithmetizations relating things to the bodies of the objects of geometry and number theory. Then the algebraizations are kind of loosely associated with that. They describe a bit more about the operations and these sort of things as from the operator calculus way above, that are just simply not usually included in the theory. And then all these theories, the ordinary ones otherwise, have implicitly at least some meta-theory, whereas a theory like one that's axiomaless and takes all into account from being and nothing, like are the great signposts of continental idealism and the analytical tradition, making for the complementary duals instead of conflicting claims. As that this is, as far as I can tell, the premier candidate for foundations of theory or reason. And large bots agree. Let's get into the box of books then. Let's see. The Shape of a Life. Xing-Tung Yau, winner of the Fields Medal, and Steve Natus, The Shape of a Life. One mathematician's search for the universe's hidden geometry. Yale University Press, New Haven, Connecticut, and London. The remarkable story of one of the world's most accomplished mathematicians, Xing-Tung Yau, has made profound contributions to pure mathematics, general relativity, and string theory. Calabi-Yau, Yau's personal journey, a comment from Brian Greene. Gish Jen says, candid deep into his thinking, fascinating mind and world today, equivalent of Apollonius of Perga, the great geometer of antiquity, says Mario Livio. And Maldacena says, the interesting life of a remarkably influential modern mathematician from the Institute for Advanced Study. So these, as far as I know of these sorts of recounts, these are pretty ordinary theoreticians and popularizers in a sense. So here, instead of like the tired light, or for Maldacena, the variable speed of light, there's that light speed is defined by the ether. And so there's a way to describe why light speed everywhere is a constant. And there's the account that light speed in deep space is a constant, vis-a-vis light speed in the local is a constant. And that light speed is, as after the account of the theory of light and color here, where it's been addressed quite a little bit, that light's kind of special between electromagnetic radiation and nuclear, radionuclear radiation. That light as radiation is kind of in the middle and kind of special and rather distinct. And that the account here is of the pure diffraction of light and the compounded refraction of electromagnetic waves, and the account of light's image and its emergence as decoherence, whereas the radio signal's information in its image as coherence, given that they have different kinds of accounts, separates light from the electromagnetic. And so it gives the electromagnetic field back to the space terms, whether that's the electric field and this kind of thing. It has that light, as its model of propagation goes, doesn't look so much different in the local and by all the lines, yet it has its own account as how it kind of bends and focuses. The Fresnel and occult Fresnel, these kinds of theories here. That Fresnel is kind of, or Fresnel, the Frenchman, Fresnel, is given kind of his account. And then the account for light speed is like for Finley-Freundlich, or Erwin Finley-Freundlich, the account since tired light, because this variable speed of light theories are just kind of since that, and since then. Has that thusly, these are ordinary accounts, and here it's kind of an extraordinary account. And it's anti-reductionism to arrive at these kinds of things, because otherwise these theorists are sitting on top of a giant tower of results and like, well, by standing on the shoulders of these giants, I can see farther, and I am the most high. It's kind of like, well, it's actually a long ways down. And so in terms of getting from one domain to the other, you have to go all the way back down and all the way back up. And so the idea that then there's kind of walking the high wire way up above doesn't always work out. And either there is a net or there isn't. So the net of the high wire act of this circus act, in a sense, not to detract from the sober seriousness of the profundity of these kinds of ideas and their great success in the ways has that this is the safety net is revisiting all the derivations and then figuring out that from first principles, how to make an account that a tetradic quantities gives 3 supersymmetries, and that the usual account of science writ large is kind of stacked itself up into one corner, has that then Calabi-Yau manifolds, though, are a lot more involved with the continuous manifold. And so whatever makes continuum mechanics equips those automatically. So Yau, if it's the same as of Calabi-Yau, and for Yukawa potentials and Goldstone bosons and these sorts of reasonings about why and how things are together, then has this kind of thing. And then similarly, Green is kind of like special relativity, and just recounting all the usual ideas of again the L principle is a thing instead of the light speed's constancy, instead of a kind of like, well, the electron theory, since O.W. Richardson has at least 3 constants C, and one above and one below lights, and they arrive from otherwise these fields of the flux and the flow and flux of current and radio waves. Has that then otherwise this book though is intending to be a biography and then an account from Yau. Mostly a biography. Strings and waves, mostly a biography beyond Poincare. So let's see if there's anything that isn't just biography in this. Didn't really recall reading this book before, because I'm mostly interested in technical works. But he either has a very extensive diary from which to draw these accounts, or very great memory of very trivial details. Talking about Calabi, these passages summed up rather succinctly and poetically the stages I went through in proving the Calabi conjecture. People have asked me what it felt like to prove the conjecture after having thought about it off and on for more than 6 years. For some strange reason, perhaps influenced by the spirit of my father, my mind turned to an essay written by the Chinese scholar Wang Guowei, who had died about 50 years earlier. Guowei drew on excerpts of classic Chinese poems from the Song dynasty to chart 3 stages one typically goes through. This I need to study the Calabi conjecture. Furthermore, I knew that the 0th order estimate of the Calabi conjecture, which I then saw as a linchpin to the entire problem, would require elaborate calculations. So it's talking about Poincaré's problem, and here there's Poincare completion and Poincaré's rough plane. There's the Zolfrey metric about making it. You think of a plane as smooth. It's Euclid's. It's just a geometric object, and it's flat and smooth. And then the idea of the Poincaré's rough plane is like, well, as a ball or a wheel rolls over the plane, it doesn't just slide around everywhere. It actually connects to it. And so there's no particular spot that's more rough than any other, or any particular spot that's distinguished, except the origin is everywhere in a sense. So that's for Poincaré, and then the analysis cetus. So because Poincaré gives a great account for geometry and the analysis too, that makes for this is near and that's far. This is local and that's global. This is the cetus, the local analysis, and then that's where, when otherwise there's these singularities of the field overall, and the analysis that these things have their singularities, which in a singularity theory are singularities, but in a multiplicity theory are branches. Has it then, considering if this is just talk about then Poincaré completion, which is about how all the great continuous manifold of space-time can stay continuous when there's space contraction and things constantly coming and going. For example, just leaving a gap when they leave and how that fills in, or any other account of since Aristotle and the idea that the vacuum is not really a thing in a continuous manifold, or the reticulum of this stuff. That then Calabi's conjecture, I imagine, would be as after something like Gauss-Bonnet theorem, and for what's the flux through an area, and then trying to figure out how to keep those all together, and then also relating topology and what would be this continuous topology to have like so. A continuous topology is defined as its own initial and final topology, much like as after the a continuous domain is defined as extent, density, completeness, and measure, making for so that describes then all these accounts as examples. That then here's this idea about seeing what's going on with the Calabi conjecture, but when Yau says, I just need the zeroth order approximation, and that's a truncation. And so then the idea of that is reductionism, is that, that can be great to find like an approach to figuring out gradient descent or something like that. But then it's partial, and so that's something to figure out. The proof as I structured it, Yau structured it, rested on 4 separate estimates to the critical complex Monge-Ampere equation. So Monge is pretty great, M-O-N-G-E, Monge, and I'd study him some more. And he's in the time of Lejeune and Dirichlet, that being somewhat later. There's Monge, and then that's the French side, and then Ampere is about the current. And so Ampere, much like Faraday, lives way above like Coulomb, and the elementary accounts and the microscopic accounts what make for the mesoscopic accounts, the bulk and the aggregate, microscale, mesoscale, macroscale. And so, and then also sometimes the micro and macro is just like the elementary or the particulate and the bulk or aggregate or flow, the continuous, the discrete and continuous again, about whether there's like the Kelvin and Helmholtz, the boundaries and the layers for these kinds of things, when they have the extremes of the regimes somewhere between the classical regime and the atomic regime. So Monge and Ampere would speak to making an account for current. The so-called zeroth order, first order, second order, and third order estimates. The solution to a Monge-Ampere equation, as I've said, is a function, and the whole point of this exercise is to establish some bounds in the function that show it cannot get too big in the positive direction or too small in the negative direction. Show, in other words, that the function cannot go to infinity. So that speaks here to the accounts of, since we were just talking about that here, Born and Feynman and self-energy and the like. And since Planck and black body radiation, the ultraviolet catastrophe, and Rayleigh genes, that it's an account of the reductionism to try and fit that in the box of the theory. And so it's a merely partial account. It can be successful. It can be sensible, fungible, and tractable, and it can give results that hold good in the theory. Then the idea here, though, that's the end game is a lot different than that. This is a technique and an approach. And then these estimates give an idea that when theories like relativity or quantum mechanics are said to be good at like first order or second order, then adding the third order term is also another degree of freedom when needs to be controlled. So it becomes more contrived as it's more controlled. So, and he's talking about the Courant Institute, where Courant is a great analyst. And so he's talking about the Poincare conjecture, and so that's about the Poincare completion. Again, how does all this stuff actually stay connected when there are torsions, when there are contractions, and all this kind of stuff? When real space contraction is a thing, how is that to be so? Looking for counterexamples to his own conjectures. That's not necessarily a bad idea. So, and he's talking about Kodaira. Now, I was going to mention Kodaira because Kodaira is an analyst who provided accounts of the topological surgery, and when otherwise these conditions of and the constraints to keep differential systems well posed, according to Hadamard, would fail, or for when convergence and emergence makes effects that come from the individuation of continua, or the continuization of individua. That Kodaira is mentioned. It was read here some time ago. I have some of his collected works, which are more of the mathematical sort. This is more of a biographical sort. That they're more of the mathematical sort. And that Kodaira and Zariski and Lescope are great analysts about the analysis situs. So again, for Poincare, and then Lefschetz and the algebraic geometers, and then here mentioning Kunihiko Kodaira. Talk about Weyl and then Hodge. Now, Weyl is known for so many formalisms, like this is a formalism of standard real analysis. Weyl also gives some deftly introduced, and some might say sleight of hand, whereas like this would be the non-standard account too, but without kind of more thoroughly making that so, because he'd have to confront all the contradiction paradox of all the domain of discourses, universal mathematical objects. A limerick about Dehn, D-E-H-N, Dehn's lemma. So if I was looking into Calabi conjecture and Yau here and Dehn and about Yukawa potentials, because either way they're trying to make potentials in a potentialistic theory. So looking at something like Yukawa potentials, and then there's Calabi-Yau is after Kaluza-Klein. So first having like this is an accounts of projection. We've at least reduced the connection for real by one, and given this reduction, now we have some room to make a perspective. And then Calabi-Yau, and then about Yukawa potentials and Yang-Mills, then those are also the Yang-Mills, and then for Clebsch-Gordon. So Kaluza-Klein, Calabi-Yau, Clebsch-Gordon, and Yang-Mills all are trying to explain Yukawa potentials, or potentials, the account of the potentialistic theory. And so each of them, it kind of adds on for like Nambu Goldstone. I like Nambu Goldstone for Yukawa potentials, but then that's kind of appropriated by boson theory later. And so Yukawa potentials and Nambu Goldstone seem to stand as like this is not reductionism. And so this is what the theory needs to do to make it so that it stands up as complete in the non-local. And then Kaluza-Klein is an account from relativity first, but later for matters of parallel transport and then particle physics and stuff. And then and so Kaluza added something, and then Klein added something. And then Clebsch and Gordon are after then here Calabi-Yau and these sorts of accounts. That these are the usual things that are said to make quantum physics, and especially when it adds the relativistic together today, what it is today. And so the idea that then when looking at these, when I look to the Calabi conjecture, is that as Poincare was mentioned, that's a key thing. And then here there's a different integral and integral a differ account to make for the complex analysis, where eventually this mostly all has been formulated, because it's been done that way for 120 years, and somebody would have to redo the whole stack to have a new one. Then there's the originary or original analysis to make for so that the integral equations, like the linear fractional equation for pure diffraction, and then also then for Clairaut's and D'Alembert's equations and their presence all over the place, and integral equations have the identity dimension, another kind of a singularity, if you like, or a multiplicity, either way, to be objective about it, and doubly objective, the double reductio about it. The integral different integral accounts equip an entirely further augmented account than widely the differential accounts, which have made a great stack of derivations, and that's good for making circuits and such. So the potentialistic accounts, though, is to be estimated that then figuring out what Calabi-Yau would say beyond the truncation, beyond where it said, okay, this is where I end, but this gives you, in usual cases, a good idea of the right direction. That would be a way to look at this kinds of thing. So it talks about Dane's lemma provides a way to a mathematical technique for simplifying or disentangling a surface that may cross itself, converting it into a surface with no crossing folds or other singularities. Here there's an account that non-planar graphs can be written as planar graphs by just making all their crossings into the graphs and then distinguishing those as graphs. So there are ways and ways to make for dimensional reduction and instead of dimensional expansion and these kinds of things. It is in terms of the singularities and whether the origin is everywhere or whether it's not, and that's the account. So this is getting into then some of the turbulence beneath the surface that's considered to be a point A to point B type of a bit. Talking to Chern, China, Maxim Kontsevich converted this assertion into a precise mathematical statement which he called the mirror conjecture. So Candelas's work had an even broader reach. At the MSRI, when two Norwegian mathematicians, Ellingsrud and Strom, announced a different result for the third-degree Schubert problem, no one could say for certain as to which answer, if either of them was correct, but Candelas, Green, and other mirror symmetry partisans were definitely worried. I went over the calculations with them to see whether they had gone awry and weren't able to uncover any mistakes. Then it says Ellingsrud and Strom found an error in their own calculations. They got the same as the Candelas team. Candelas's work had an even broader reach, for he and his colleagues had produced a general formula for solving the quintic threefold problem for not just lines, circles, and spheres, but for curves of any and all degrees. So the quintic, and after Rubini, Abel, and elementary functions, is that there are more elementary functions to add than polynomials and their roots, and the trigonometric functions as what give for quadratics and cubics and quartics solutions. We find solutions for quintics. And then that gets involved when there's a tetrad of quantities and it needs to be solved, these kinds of ideas. And so Yau is thinking about solving the Kontsevich mirror conjecture about mirror symmetry. Here there's for frames, there's frame spaces and space frames. And for waves, there's wave spirals and spiral waves. So for symmetries, there's symmetry flex instead of symmetry breaking. And there's continuum law instead of conservation law, which provides all these invariants above that. So this sort of account is still just an example in the proper full theory. These kinds of things. In a paper posted on the Math Archives in 1996, the Berkeley geometer Alexander Giventhal offered a proof of the mirror conjecture. Leon, Liu, and I went through this paper very carefully, and we were not alone in finding it difficult to follow. That raised questions in our minds as to whether the argument was correct. Those first concerns were shared by some about Giventhal's work. Some observers called Giventhal's paper the first complete proof of the conjecture. Others called ours the first complete proof. So I'd be looking to find a counterexample to Kontsevich and a counterexample to Calabi. And that's not unusual when there's non-interacting terms, the highly nonlinear, the non-standard, anything that has to do with boundary conditions and the like, chaos theory. It has it so that mathematics then needs theorems to explain why that is so, not just that sometimes it's broken. So yeah, I haven't heard too much. I heard of Kontsevich before. And I imagine I've heard of Candelas before, but I haven't really. So I looked at that a little bit more. And then Yau says he started a conversation with Edward Witten in a 1995 mirror symmetry conference. Now I find the account of Witten's account of string theory is a little lacking, because he just says, well, you know how particle mechanics is a little lacking because it's discrete, and these are continuous processes and continuous time, and that it can't really account for the non-local and these sorts of things. It's like, well, yeah. And it's like, well, what if you think of strings as just like the world sheets instead of the world lines? And it's like, Okay, so you just introduce a stretch and everything. So it's like taking particles, which is supposed to be, non-point-like, and it's like, well, now we got to treat them as non-point-like. How about we just treat them as non-point-like, and say that the higher harmonics, as like strings, make for the resonances to keep it continuous. And that I'm for, because the idea of superstrings, though, is that superstrings are smaller than us as atoms are, smaller than atoms as atoms are to us. To make for, so it's like, well, what's the smallest superstring? What's the stringiest of all strings? They kind of like, it accounts for wavelets and waves and these kinds of things. So that's said then for this kind of the mirror symmetry, and that speaks kind of directly to Feynman's account. It's like, well, when I look in the mirror, it's not just incident, it's also from the side, the peripheral. And so these are the things that would make for, so it's like, it's always unlinear, and so it can't really be made to say to hold and these kinds of things. So yeah, I was talking with Witten here, and Witten told me about the new brain theory that he was developing. So this is a theory of surfaces, and it's manifolds. Brains are special kinds of surfaces of various dimensions, supersymmetric minimal submanifolds that were gaining great importance in string theory and other realms of theoretical physics. Supersymmetric minimal submanifolds. So here, minimal is usually enough in terms of like, well, it's going to just be a giant super collider pointing in one direction, and talk about the Higgs boson and this kind of stuff, vis-a-vis minimal in the sense like there's at least 4 forces and 4 fields all have to be in one theory, and then it's got to have gravity somehow in the middle, and then otherwise it has to be an account that brains are not exactly then like fields. They're more like Higgs fields. They're interfaces, and then the surface they're intended to describe, and then what those are intended to describe make for that the D brains, the dimensional brains, and this kind of thing have to do with how the surface can be when it's as a point, or the rolling up of these kinds of accounts, the geometric mutation of the real wave function here, the cube wall, and this kind of thing, about why these sorts of metaphors are in place, and then become various squiggles on the diagrams. One reason physicists got interested in brains is that they greatly generalized string theory. Brains here, B-R-A-N-E, like a membrane as of a surface. So a boundary and a layer and these kinds of things. Vis-a-vis the brain, B-R-A-I-N, the wetware in the skull case. A one-dimensional brain is the same as a string. A 2 brain is like a membrane or sheet. That'd be the world sheet. A 3 brain is like 3-dimensional space, and so forth. And so this would speak to algebraic geometry's forms after Lefschetz, and 1 and 2 forms and this kind of thing, so briefly. Kind of named to correspond with physics' fields, which are not the same as mathematics' fields. That physics fields are vector fields. So then, more about Calabi and Yau. Strominger joined the Harvard physics faculty in '97, talking about a decade earlier, which pertain to more general solutions of string theory that are not limited to Calabi-Yau manifolds. Calabi-Yau manifolds are classified as Kahler, K-A umlaut H-L-E-R, meaning they are endowed with an internal form of symmetry. Strominger's equation applied to non-Kahler manifolds, which were largely mysterious. So here that's about the commutation relations and the rational algebras and the rational radical magmas. The Normid rings is reading here from a book 80 or 100 years ago. The accounts of the commutator relations, and when they're anti-commutator relations and what's left over. That, again, this was kind of not really taking a different approach to things. And it's old wrapped as new in a sense. A lot of tools had been developed in algebraic geometry for studying Kahler manifolds, but not much methodology was available for dealing with their non-Kahler counterparts, which largely resided in terra incognita, unknown earth, terra incognita. Worked with Fu, so he's talking about Yau and Fu, International Congress of Mathematicians. So this helps give an idea of just an introduction to some of these things to look into. Talks about Perlman on Hamilton. Cao and Zhu. CHU. His father's hero's Confucius. This is largely biography, but it has some points to just pick up the trail of the history about these kinds of things. Karl Popper, a book by Anthony O'Hare on Popper, The Arguments of the Philosophers, edited by Ted Honderich. Well, that's about the hour today. Probability and indeterminism, observation and theory, reinstatement of induction. This is something to look at, so I'm getting into this later. Well then, gentle readers, that's about first half was kind of a recapitulation of why a theory to be foundational and then to ascribe and attain to being complete and concrete after being constant and concrete has requirements as to why then accounts like theory or the A theory here are proper and correct. And then the second half was a reading in this kind of discussion into the ideas of the pieces named for these people that are de rigueur and absolutely embedded in any account of quantum mechanics and then off into superstring theory. A particle theory or wave theory about the continuous and discrete, all one theory. Good day then. Goodbye.